Hello everyone, I am Vivanshala. Welcome to my YouTube channel, Space Engine. This is a series of short videos in which I will explain some concepts about the universe, as such, theory of general relativity, dark matter, and particle physics. I will upload every day, so stay tuned. I hope you enjoy.
Today's topic is the birth of elements. No one has gone to the sun to take a sample and return. So how do we know what elements the sun is made up of? One tool for this is called spectroscopy. It is made up of a process of refracting the sun's light using a triangular prism. This causes the light to split into separate colors, and if you use a more advanced device, then you can do this with much more accuracy. The process is the same as the light coming from the sun is let go through a device, for example, grading device, and then you can separate light all the way from red to violet. However, some spectrums don't have certain colors and have black strips randomly spread across the spectrograph. Sodium lamps in certain places emit yellow light, and for each element there is a different color which it emits and absorbs. As a result, these missing colors or black lines on the spectrograph are like a fingerprint for an element. As a result, we can find what elements a star or planet contains. The sun is shedding its mass and converting it to energy, and to prove this, we would like to verify that neutrinos are indeed coming from the sun. This is because in the sun, to produce helium, hydrogen nuclei go under a complex process which releases neutrinos, but they don't interact very much with normal matter. As neutrinos have such a low probability to interact with anything, you need a big target. If the target is big enough, there may be some small chance that the neutrinos might cause some reaction inside the big target. According to statistics, you may be able to see 5 neutrinos a day even in a very big target. But if you just wait long enough, for example years, and keep recording these neutrinos coming from the sun, eventually you can take a picture of the sun after a long exposure. The Super K took a picture of the sun's core with neutrinos in pitch darkness, 1 kilometer underground, but the neutrinos can penetrate the entire 1 kilometer rock very easily and can cause reactions. Very small number of them, but by accumulating and waiting for enough time, then you can take a picture of the sun. All the stars would come to an end, and the bigger the star is, they will live shorter. This is because the bigger star would end up with a big explosion, and that would let all the outside of the star just fly apart, and the only thing that remains is the core, with the gas cloud to spread out and collapse into a star again would be very difficult. And if the star is big enough, the core turns into a black hole, as the gravitational force exceeds the force at which it radiates matter. If it is slightly lighter, it doesn't go all the way to form a black hole, but leaves a very tiny dense core called neutron stars, which are only around 10 kilometers in diameter. And if the star is much lighter, like in the case of our own sun, it does blow up, leaving dense objects called white dwarfs. So depending on how massive the star is, they have different lifetimes. Stars form bigger and bigger chemical elements as they age. A star burns hydrogen to build helium, and that can happen even in a fairly smallish star like the sun. The hydrogen can go to helium. Then the star move on to building other big elements like oxygen, and they continue till they reach iron. The Big Bang produced only hydrogen and helium, and no other heavy elements, and these led to the formation of some stars, and inside the stars formed the bigger elements like carbon, oxygen, silicon, all the way up to iron. And as long as these elements are stuck inside the stars, we still don't get to use them to form all the objects inside our world. So it doesn't explain where we come from. But this is answered as stars can actually explode at the end of their life, and that would release a lot of stuff back into the outer space. And then what had been synthesized at the core of these stars gets released like carbon, nitrogen, oxygen, and iron. That would eventually form a body. So what is believed is that our sun is probably the third generation star. So we had the initial stage of the star formation based on the hydrogen helium alone. Some of them exploded, which led to more stuff. You accumulate them, and these create our solar system and planets. And the second generation star would have caused the formation of the Earth and every living thing which lives on it.
Thanks for watching. Please share your thoughts and ideas in the comment section below. Bye.